Hey guys, let me know if you can see my screen and you can hear me. Hey David, Preacher, Jacob, Ashok, hey Reese, hey Mark. All right. How are things going? Hey Jason, Jesus, Ari, Rachel, hey Ed. Okay, so how are things going? Any questions, anything on your guys' mind? You should be able to see my screen. Ashok is saying can't see the screen. Frank can't see the screen. Okay, 1 second. Show. I'll share it again. Can you see my screen now? Frank, it was visible and then it's not. So Noah sees it. Can you guys give me a shout out? Can you see it or not? Just give me a yes, no. Then I have a sense of how big a problem it is. Okay, all right. Well, it shows up. Mark says it's still C a high. Yeah, that's good. Okay. All right. So it's coming across, which means it's recording. And there we go. Okay, a couple of questions up front. Aaron, is it possible when you've drawn out an insert sphere to use radial symmetry local to that sphere rather than the object as a whole? No, you'd have to break it out into a subtool before you could do something like that, which is easy enough to do. Okay, there's one more question. David, someone asked about the blur on Dynamesh. What does it do? So one thing to keep in mind, you can always come in here and hover over an interface item and press Control. And almost everything has a little blurb about it, this kind of inline help. And what it's telling you here is that it's going to apply a kind of, it's going to modify the smoothing. So you'll notice that right next to blur there is this little dot. Let me turn my screen draw program on. The dot's a new feature, and it's been put in several places. Okay, so you've got the dot right here, but you've also got it under deformations with these polish features as well. Polish is a form of smoothing. Relax is a form of smoothing. So this is telling us right off the bat that there's a particular kind of smoothing that's been implemented. In almost every place it's being implemented the same. I think under edge loops there's a polish, there's a feature here, then there's the polish here as well. And there's one other place, clay polish. Did they put it? No, it's kind of a different beast, that one. Okay. So the two different kinds have to do with whether or not it listens to you know, internal curvature, whether or not it listens to the overall boundary of something. One's more extreme, one's less extreme. That's basically the easy way to think about it. And you're not necessarily going to be choosing one or the other based on surface contours. Your decision-making process is largely going to be, do I want it really smooth or do I want it kind of smooth, which is similar to this project button. So if I've got a form in here, let's take this dog. And I'm going to just get rid of the fiber mesh. And let's just delete that. There we go. I'm going to turn off, let's turn it off here, color, and give us a different material. Okay. So here with Dynamesh on, I can Dynamesh this guy, get completely new topology. Sculpting topology, right? And we know we can adjust the resolution for larger or smaller bits. If we change our blur, in this level it's not going to do too much. We've only got our blur set pretty low. I'm not going to set it to 100. I like to set my things a little bit in ZBrush below 100. And the reason for that is because 100 inside of ZBrush has some ramifications. It's got some funky math. Occasionally on some of the features, and I don't know which one it is, so I don't bother asking. I just kind of generally keep it kind of off the 100 mark. Okay, so we've got blur set there. All right. You can kind of see a little bit of the difference. Some areas are smoother, but the resolution on this is so high that you don't really notice it too much. Let's see if we get a slightly different result by changing that. So blur with the closed circle, which is, I think, the dot, or the open circle, which is a circle. Then you've got, so if it's open circle, then you've got what we're seeing here, which is a really broadly applied smoothing algorithm, and it does no internal checking to see, you know, maybe it's doing it too much, it's collapsing too much here or not. There's nothing. It's just we're going to apply the same smooth here that over here. We're going to apply the same smooth that happens to the neck. We're going to apply that to the back of the leg. We're not going to do any checking to say, hey, this is a thinner mesh, so maybe you shouldn't smooth it so much. So I hope that helps, David. James wants to know adding something to an interface. So yeah, I can show you that right now. Laszlo, I hope I just answered the question you asked. You asked a minute ago, but the answer is that they're just different smoothing algorithms. Okay, so let's see. James, you wanted to know about adding something to the interface? Okay, so it's real simple, but you need to be aware of, in preference, this whole side of things. You need to be aware of the standard UI and the store config. So that's really important because as we do this, you're going to store the config, and if something gets screwed up, you can always restore the standard config. So with that done and said, let's get in and start to customize things. Notice I've actually already kind of customized a little bit, so actually let me just restore standard UI. There we go. All right, so how do I grab something from here? First thing you got to do is you got to go into, what is it? Config, enable, customize. That's the first thing, okay? And remember, hover control, in case you're not here, and you don't have me or you don't have support, and it'll tell you what to do. So press Control Alt to drag controls. Okay, so you're just turning that on, and then there's a couple of things to be aware of. You have areas in which you can add stuff. So I'm going to just grab something and I'm going to move it around. Let me say I'm going to grab this this matte cap material. No, I don't want a matte cap material. Well, we could. I'm going to press Control Alt, click on it, and now I'm moving it. So I could move it here. Anybody remember what this is called? I can move it here. This is this kind of hidden toolbar here. Nobody puts anything in here usually because it takes up interface space. You can drop it down here somewhere. Not a lot of room. There's a space right here underneath the canvas, and then there's a space right here underneath the ZScript window. I've got space over here in the side, and I've got space, not in the trays. So this will give you a sense of what you've got here. And let me delineate it. So you got a space, 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 and space. So you can put them in the shelf anywhere you want. This is largely the shelf with these extra shelves, pull-out shelves, so to speak, top and bottom. Most people will put stuff here along the bottom and then in the shelf here. Now I have an older Cintiq here right now, so this aspect ratio is a little bit different. And then also I'm using this at a very low resolution, 1280, because I'm broadcasting this to you, and that just goes over the interwebs easier. So you can see I'm missing things like the solo button doesn't show up on my screen, things like that. So in your interface, you're going to have more room than I have, a lot more room. So let's do something functional. I might like to take alpha, create, no. I might like to take brush, curve. I just had a ZBrush 2 moment, in case you didn't catch that. I'm going to go brush, AccuCurve, and I'm going to press Control-Alt, and I'm going to drag it right there. I like to keep this in my interface because it's pretty awesome. It has effect on a couple of brushes. I'll show you. When we're done, we go Preference. We turn off Enable Customize. You'd come in here and say Store Config. And then every time you start ZBrush, you'll have it there. And it's as simple as that. So I hope that helped. James, let me know if there's any questions. And while I'm waiting, I'll show you guys what this AccuCurve does. We'll talk about it later, but notice the Move brush. And now with AccuCurve. Doo-doo-doo. Okay, let me check in. Any more questions? Noah, let me know. Do you use Maya Max XSI? And you're saying, I don't understand why Pixlogic wanted to take away the subtools. They don't want to take away subtools. Not at all. But when they implement a feature, they want it to have a lot more impact than the initial problem. So Noah, when Pixologic's looking at a user request, hey, I want to be able to organize my mesh, and I would love like an outliner inside Maya. Well, that's the initial user request, which comes from an initial problem that a user has and something that they would prefer. And as a software company, you can solve those problems. But as anybody who's been in software knows, if you solve all your users' problems, you end up with basically software that's got 20,000 menu items and a kind of confused philosophy behind it. And since Pixologic's highly optimized, their team was very small, stuff like that, then everything needed to be highly efficient. And so subtools couldn't just solve that initial user's problem. It needed to be highly efficient and solve 10 user problems, as well as look into the future of computing and figure out how it could solve really large-scale problems people have, such as polygon count. Hope that makes sense, Noah. It's not that they want to take it away. It's just that they want to make it better than anything before. Hey, Peter. Good to see you here. Anthony, I think Nate may have answered your question a bit, but I'll look at it here. You could not up the res in your Dynamesh above 64, and it would not let you put holes. Wow, that's kind of crazy. That'll be something we have to take offline outside of this, because you should definitely be able to take that slider up above 64. Jason, I'm having trouble duplicating the mesh so I can upload 1 or 2 extra meshes for project review. Duplicating the mesh for upload, for review. So Jason, I'm confused. Are we talking about, say, duplicating a model, which would be the clone brush, or the clone feature in tools? And that just gives me another guy that I could export? Or are you talking about grabbing your screen for a 2D image so you can put it up into UART? If you're talking about grabbing your 2D screen, it's both easy and a little hidden. It's under Document and Export. And I'm looking at it on another screen, but then I'm going to say choose a JPEG as a type. I'm going to replace that. And then it gives me this cool screen with these kind of cropping mechanisms, note about the file size, quality, any kind of contrasting that I would like to do, and then down here, you hit OK to save that JPEG. So I'm not sure whether or not you're talking about exporting the screen or an OBJ. And since you said project review, I'm assuming you mean the 2D way, because that's what UART uses. I'm going to cancel out of that. Frank, older question, can you elaborate on subdiv layers and freeze? Oh, I wasn't seeing people posting responses here. Subdiv layers and freeze, can I elaborate on that? Let me see if I can elaborate on that today. I think any way that I elaborated on right now might be deemed esoteric. So let me think about that. Anthony, it seems as though when I Dynamesh, it converts back to the lower subdiv level. Do we have an easy to access project with subdiv levels? Let's go into our tools. Usually I store something here. No. Okay, one sec. No saving of that. Let me pull up a, you know what, that's going to take too long to go through all this stuff, I think, but let me see if I can find something really quick. Okay. I'm not sure how large that file was. I didn't pay attention to it. Okay. Let's just get this in normalized material so we're not going all crazy. Okay. This is done a while ago. Let's see. Does it have subdiv levels? Yes. It's got a lot of complexity, like these negative shapes, things like that. And so now we want to figure out a couple of problems. Okay, let me go back to the questions. Anthony, when I go to Dynamesh, it converts back to the lower subdiv level. Well, that's exactly what it's supposed to do. Basically, a lot of these features will be integrated with subdiv. Yes or no. It's a choice when a feature is created whether or not it's able to integrate with that. And most of the time, the easy, straightforward route is no. Because subdiv levels require a whole bunch of extra code to make them work, so they're usually something they implement later. But you'll see this in a lot of features. They require you to turn off your subdivision levels. And so Dynamesh will work on only one subdivision level. So if I was to come in here and say Dynamesh, it asks me to freeze it, right? So now I can elaborate on the freeze idea. So let's say I hit no. Let's give some scenarios. So right now my model consists of a subdiv 1, 2, 3, 4, 5. Okay, in subdiv level 1, I'm going to have like just the outline. Okay, on subdiv level 2, I'm going to have like big bumps. Subdiv level 2, I'm going to have littler bumps, tinier bumps, and then maybe little scratch marks in subdiv level 5. That's one way to think about subdivision levels, is that they're storing different levels of information. It's a lot more complex than that, a lot more. But you can think about it like that for now. So if I freeze the subdivision levels, then ZBrush is going to store all of this information for me for later use. So it takes all this information, puts it in a bucket over here, and we're ready to go. So if I hit yes, then it's going to move all of that into a bucket that we are able to pull in later. Okay, if we hit no, then it's going to take all of this and it's just going to throw this in a trash can. So let's see, can I draw a trash can? There we go. So it's going to either throw it away or it's going to keep it for later. That's what freeze is basically saying. And if we keep it for later, we put it in memory, and then as soon as we want, we basically reapply it. We add that back into the mix. If you say no, then you're throwing it away, and that's the end of the story. So Dynamesh is only going to work on one subdiv level. And that means you have to decide, do you want to keep it or do you want to throw it away? If you throw it away, now it's telling me I've got layers. So let's just pick all the layers. We don't want to go into too much of that right now. And also, when you're working from one version to another version, layers is one of the features that can get a little funky. It doesn't, I haven't seen them always code things correctly in that sense. So give me 1 second. I'm going to undo the damage here. I'm selecting a flat color, mRGB, and I'm going to go color, fill object. There we go. Layers store color and material information, so they, if they're not coded correctly or updated, then it'll cause that kind of thing that you just saw when you bake it and all that nonsense. Okay, so we've got that. We're going to go, and this has not been Dynameshed, even though Dynamesh is on. So I'm going to press Dynamesh now, and I'm going to say no, don't freeze. Okay. Resolution is high. I'm maintaining a lot of stuff. The teeth are a separate subtool. So I'm maintaining a lot of detail in there. Now, if I was to do that again, and this time freeze, first it goes down to the lowest subdivision level, and then you have to Dynamesh again. But I got a problem here. Anybody want to tell me what the problem is? Anybody want to tell me what the problem is? closing holes, reprojecting details, messed with the shape. I mean, those are all problems. He's bit, that's definitely a problem. But no, I've got a system problem, system-wide, something that's going to cause me some headache here in a moment. I mean, he's got problems, he's biting himself, all that stuff. Jason's got it. Too many polygons is a potential problem coming up. So let me undo this. I'm going to unfreeze. My model has 2 million polygons. At the highest, at the lowest, it's got 7,000. So we're going to go through this process again. I'm going to Dynamesh. I'm going to say yes, freeze those levels, put them in memory. Now it's gone to the lowest and froze it, but it needs me to do that next step, Dynamesh. My model is now 100,000. So I went from 7,000 on SDiv1 to 100,000 on SDiv1. So as soon as I take everything back out of memory, remember over here we've got our memory, and this has got, 5 SDiv levels. What is it going to do? Well, really memory's got 4 SDiv levels. It's going to put those back in. So now I'm going to have, instead of SDiv level on 1, we're going to have all the way to SDiv level 5. So who knows the math for subdivision levels? How does it function? Each level adds how many polygons? Jacob's got it times 4, right? Because every polygon is divided not just in half, because that would be weird. Instead of a square, then they become rectangles. Even if you divide it the other way, they have to be divided like that. So every polygon gets divided like that. So that adds, for every one, it adds 4. So now 1,000 is going to become what? 4,000, or 400,000. That's just for level 2. So then level 3 is going to become what? Times 4, that's 1. So on level 5 before, we were already at that number, but now we have 2 more subdivision levels. So now this is going to become, anybody good with math? I'm fast with an iPhone. So 16 times 4. 6,400,000, then subdivision level 5. Now I got 64 times 4. We got some serious problems. Is that accurate? So if I was to unfreeze, you're looking at somewhere around 25 million polygons, which, as David says, equals crash. So hopefully I've elucidated freeze and the Dynamesh problem. Let me go back and look through the questions. Okay, yes. Anthony's question. Okay, and then there's some questions on how to snapshot. Jacob's got the answer. Okay, we can talk about the scale. All right, let me see. Jacob. So you want to avoid Dynameshing lower subdiv levels if you're going to unfreeze. So Jacob, the answer to your question, it's not that you want to avoid, it's that instead of setting my resolution here, I would set my resolution significantly lower, like 32. now the polygon count is essentially identical. So now I can unfreeze, let it do its thing. It can take a little moment and the computer's going to freeze up. So I'm able to talk much. Okay, let me give you guys a second. My computer overloaded. Can you hear me? Just give me a shout out. Just a few people. You hear me and see me. Okay, good. Great, thanks. Okay, so now we look at our model. 1,700,000. So it's not a matter of avoiding subdividing your lower levels. It's a matter of make sure your resolution, make sure this little slider right here is set appropriately, because if it is not, then you are looking at a crash. And freezing and unfreezing will have no longer mattered. When you freeze and unfreeze, the masked areas, these are projected. So those are successful. The unmasked areas, not successful. So they mask them because maybe at this point you need to resculpt the bad areas. So you might throw these things in and kind of hide them from view, you know, or whatever you're going to do. But at least this is an easy way to get at them. Okay. Thanks, Anthony. All right, let me go back up to the questions. Okay, we did the interface. We did the upload. Snapshot, I think, was already answered. And Ed was asking the relationship between scale of a mesh and Dynamesh. Oh, Ed's talking about it's not really an issue with scale and Dynamesh as much as there is an issue with scale and ZBrush. So let's say, for example, it's Ed is talking about a problem with real-world measurements. So this is useful for us to talk about right now. I do talk about it in the lectures. So I'll talk about it now, and then we'll go from there whether or not it needs to be chatted about more. Okay. So real-world measurements. We know ZBrush does not work with real-world measurements, right? When you're inside ZBrush, you're inside a box. And inside that box, you're dealing with ZBrush units. Okay, and that box is basically the canvas. You're looking at the edge of that box right here. This comes from the old school, the way ZBrush used to work, which was that it used to be an illustration package. So all of these little squares inside here, based on your resolution, depends on what your screen's resolution is, your canvas resolutions, all that's stored up here in documents. These were called pixels. Okay, and we talked a little bit about memory yesterday, but pixels store X, well, let's keep it up here. They store X and Y information because it's X and Y on the screen. They store Z because pixels also go back in space. They also store RGB, and they also store A for alpha. So if you're working inside of Photoshop, you only work with X and Y and RGB as well. And I think they've got alpha depending on what's happening. The Z is really the mitigating factor here because it means that your canvas is roughly 8,000 units deep. You don't know that. It's not set in stone, and that could have changed from when I worked there. And you know, it's not something you necessarily need to know, but it's 8,000 units. So for every one pixel you have here, there's 8,000 of them going back in space. Now, why do you care about that? Well, it affects memory usage. So it affects the size of your document. So your document here, you're rarely going to set a document at 4K inside of ZBrush. Don't do that to yourself. That is pain. Instead, what you want is you want to set one of your measurements above 2K. Height, width, whatever. Get it above 2K. Try to get both of them above 2K. And then you go into Photoshop and you use resizing mechanisms from there. So Genuine Fractals was an old one. That's changed. I think it's been renamed. But Photoshop has some pretty awesome resizing algorithms as well. Going to 4K is not as simple as going from a 2K in Photoshop to a 4K in Photoshop. The amount of memory that increases from a 2K to a 4K is exponential because you're talking about this 8,000 extra units of depth. So 1 pixel equals 8,000 pixels in essence. You know, there's ways to optimize, and of course it's not holding all 8,000 of them in memory because there's nothing there. So there's easy ways to cull it, to remove it, but it's a heavier load. So that affects us in the sense that because of this old school approach of the pixel, and well, because of this, our canvas and the area that we operate with inside of ZBrush is not hooked up to, say, Maya's viewport, which is in Maya or Max or Lightwave. They work in real-world units. It's OpenGL. They're using algorithms that have been created by other people at universities and then tweaked by them and different people. And who's run into problems inside of Maya with the graphics card? You know, this is less and less of a problem now because OpenGL and all this stuff's been around for a long time. But, you know, when ZBrush was doing its thing, Maya had a list of graphics cards that were approved and not approved. So this graphics card was okay, you could use that, it was strong enough, things like that. And that's when ZBrush or Pixologic was deciding we're not going to force people to do a graphics card because it's not a hobbyist, it's not amateur, it's like at that point you need to be hardcore because you're putting a graphics card in. Easy for you and I, but for the audience that Pixologic wanted, which is the world, which is traditional artists, which is people who just want to kind of explore creativity, you know, there's a lot of stuff there. Installing a graphics card is way too hard. So they, instead of going with real world, they decided to create and stay focused on their own technology. So it went from Pixols to ZBrush units and kind of all ramped up from there. So all of that takes us back to the real world versus ZBrush units dilemma. And so I can say, do a little diagram that'll give you a sense of things. ZBrush assumes that you are, you know, working on something that's roughly human-sized. If this is Godzilla, who's seen the movie? I haven't seen it yet. This is the little person down here. And then this is like a city in the background. Then we're going to run into problems. What ZBrush is going to try to do is going to try to take your Godzilla and he's going to try to shrink him down into human size so that he fits within the ZBrush world, which let's just arbitrarily sketch as a little bit larger than humans. This is not to scale. I'm not putting that to scale. The workable space inside ZBrush is much larger than that. But it'll give you a sense of there's occasionally problems. All right, let me check in. I'm getting a lot of, I got a long list here, a lot of notes. Okay. All right, Ed, let me know, did I answer that? Did I give you something to work with? Peter, really, I'm glad you like that model. He's got to get finished one of these days. I got to learn about this Wendigo. I don't know that. Preacher, can you use ZBrush to get this under control? I'm going to clear this screen in case anybody wants to be saving that. You can use something different than ZBrush. You use Unify. That can help. Another thing you can do is you use Unify, and then you export, then you select the star. Okay, I'm going fast here. Select the star, and then you import. Don't worry, we're going to talk about that. There's a trick where sometimes you need to make ZBrush forget real-world units, and it might latch onto and remember things, so you force it to forget, and that's by exporting it and re-importing it. But don't worry, there's a whole module on exporting. I do not expect you to remember what I just did that quickly. Okay. And Aaron, I like this. Would reconstructing your lower levels after Dynamesh before unfreezing work? Yes, they would. James, is there a way to fix the byte closing up? The way you do that is by increasing your Dynamesh resolution, and that's what creates the freezing problem. So you go higher here, and as Aaron mentioned, for those who are more pro, you can just Dynamesh it low, and then you can ZRemesh it, or you Dynamesh it high and then ZRemesh it low. Frank, so subdivs are just to keep the poly count low in sculpts. No, subdivs are, they're dynamic resolution sculpting. So subdivs, yeah, I mean, I guess you could say subdivs are a way to keep the count low in sculpt. Because, for example, in the olden days, it was much easier to sculpt at a lower subdivision level. So let's undo this guy and all this stuff that's happened to him. Let's go back to his original. Okay, so in the olden days, it was easier to sculpt this many polygons and then slowly go up. And then when you were at the highest subdivision levels, you knew what was going on. So it was a way to control how quickly you used systems resources. And Noah, games sculpts at high resolution. Don't forget that. You say for games, high poly wouldn't work, but everything is sculpted at high resolutions, and then it is remeshed. Aaron, great point. Pixels store surface normals. So Aaron was mentioning that there can be a ball inside here, and that means it's stored X, Y, and Z, right? It's storing R, G, and V. It's storing alpha, but then it also stores whether or not that pixel is facing an X, Y, and Z tangent. So if you didn't get that, don't worry. Normals, we'll talk a little bit about it, but it's just, pixels are pretty amazing. Ashok, what is the difference between Dynamesh and ZRemesher? It's a real simple difference. Dynamesh is something you use to help you sculpt, to add something, to integrate. It's for when you need help sculpting. ZRemesher is for when you need to output something or you need to optimize topology. You could see them as the creative side and the production side. So Dynamesh is when you are on the creative side and you don't want to think about topology, you just want to go. ZRemesher is when you need to think about topology because something's going wrong. Hope that helps. That's just an easy layman's way to describe it. Okay, one more, and then we gotta get into the lectures. Anthony, I didn't know that. It's good info, great. Export the mesh. Yes, okay, good. Glad that helped. All right, Ashok, glad that helped. Seeing how the bite closed? No. So, okay. Okay. So, I hope that answered your guys' questions. And now today what we're going to talk about is brushes. So brushes is the order of business. How you create your own, how to understand them. Brushes are really the heart of ZBrush. I mean, it's in the name, of course. But it's also one of the most kind of heavily developed early on. So the easy way to think about this is Maya has the paint effects brushes and they have that sculpt brush. Has anybody used that thing to try to do organic sculpting with? That little sculpt brush inside of Maya? Well, that used to be, you know, de rigueur, like that was an important, significant tool. And that was the technology of the day. When ZBrush came out, there were companies that had literally decided it was impossible to do what ZBrush was doing. Impossible. It was just not possible, which is technically true because the companies that were looking to do this were using OpenGL. And in OpenGL, it's not optimized. It's you know, it's done at universities. It's, you know, it's not optimized for the racetrack, which is what ZBrush is really all about, getting something very specific done. So ZBrush had to develop its own OpenGL. It only uses like a couple of parts of that, a couple of libraries from there. Otherwise, ZBrush is its own OpenGL. So it was impossible until somebody invented this new ZBrush GL, so to speak. And the brushes are a really significant part of that. So what we want to do is we want to talk about brushes and we want to understand, you know, how these things work. So there's a couple of things to kind of keep in mind. So the course of this lecture should, if we stay on track, should be about the basics. So what are the basic elements that constitute any and all brushes and affect pretty much any and all brushes the same way? Then we're going to talk about the algorithm versus the modifiers. So what does the type of brush, so clay brush, standard brush, what does that do versus the algorithm or versus the modifiers that can change behavior, things of that nature? Then we're going to talk about the stroke versus the hand or the tablet. There's controls for the tablet. Then we're going to talk about alpha versus geometry. Okay, so you can create a shape using an alpha. We all know alphas from Photoshop, things like that. The stencil is an alpha. In Photoshop, you'd put an alpha would be like the shape of your brush. But when you're in 3D, alphas don't need to be alphas, you know, anymore. Sometimes you could use an alpha to create really complex things. And that's where this line blurs between what's an alpha and what is actual geometry. So that's when you see the insert brushes. Okay, and then we're going to do some brush making. Okay, how do you make your own brush? So think about a brush that you want me to create, and I'll see if I can figure out how to create that, and see if we can kind of pull it together. All right? Okay. So now first thing, brush basics. So let's throw the brush tablet off to the side here. I'm going to go open this. I'm going to grab the little swatch and throw it over there. I'm going to press this R, which just restores it to this kind of simpler configuration. Because as you select brushes, they get added to this little inventory section here. All it means is their icon gets added. And so as you select brushes, that can kind of get super long. And then I just press R. So for example, I'm going to come in here and select, let's select Deco. It gets added. I'm going to select Layered. I'm going to select the Insert. You can see everything just starts dropping. R to kind of fix that. Let's close the curve. We already saw that little feature. So let's close this tray, and I'm going to close both trays. So right off the bat, in the shelf, these are obviously the very important features that relate to the pin itself. So you've got Z-add, that means pull out. Z-sub means push in. Okay, Z-intensity is an overall strength. Focal shift and draw size. So draw size is equal to how large is the brush. Pretty straightforward. Focal shift is really related to hardness. It's another way to say it. So that means by default, let's do it a different color. Focal shift is, kind of in the middle, and then there is this softening between the inner and the outer band. But as you go, you can decrease that focal shift, and then that means that the gray area, the softened area, is significantly less. Or you can make it really small, and then you've got tons of softening of that effect. This is a very early feature. Very early. This is before alphas were very significant, in fact. This is kind of a pre-alpha feature. So I'll demonstrate that real quick. Let's go into the standard brush, and let's work on his back. And am I at the highest subdiv? Yeah. So we have Z-add, you know that. Z-sub, you know that. Push in, pull out. Okay, we're going to increase the draw size. You know what that does. Now we're going to decrease that focal shift. And now the edges of that brush get harder, or we increase it, again staying away from 100, and the effects become very minor. You can do the exact same thing with an alpha. You just come in here, and let's say we got alpha 01, and then we're going to come in and go really hard-edged like alpha 14. And then we're going to come in and go really tiny like alpha 36. Same exact thing. Focal shift is just earlier in the equation, so to speak. Now, focal shift does still affect your alpha, if I remember correctly. Let's put that to the test, in fact. We're going to go hard edge, and we're going to go really soft focal shift. And then we're going to go really hard focal shift. So you can see a little bit of the difference there. Actually, that's the best way. Focal shift is still having an impact. Again, focal shift is defining the area that is blurring. So this alpha will naturally be hard, like a really hard alpha will naturally be hard within this quadrant, and then it's going to soften. So if you really need it to be hard-edged, you got to think about your focal shift. I'm seeing a couple questions pop up about that. Okay. Norman, not that I know of. In terms of that. So focal shift, we've got their alphas in here, and these are the early alphas, real simple, real straightforward. Okay, but you can kind of see some of the problems we're having with strokes. So stroke is one of those things that's really significant for brushes. I'm going to throw stroke over here to the side. And let's do the hard shift. It's under draw. Let's leave focal shift kind of hard and with this alpha. Right now I'm using the dot stroke, and within the stroke palette itself you see all these different guys in here. So there's one of these called freehand, and these are the old brushes, dots versus freehand. This is the old dilemma that Pixologic had when it was working with strokes. Dots was supposed to be kind of the low end. If your computer wasn't fast, you used dots. And then freehand was supposed to kind of automate that based on your system's behavior, things like that. As computers grew and as ZBrush grew, freehand became less useful. We needed something that was much more powerful because people were sculpting at higher levels of geometry. Levels where before they used something like Projection Master, now they sculpted by hand. And this really kind of drew ahead with guys like Neville Page, who sculpt really amazing flesh in realism. And this brush was just not working for them. But there's also something else to be mindful of. I'm not sure if you're noticing, but as I draw and move along, there's a little red line. A lot of brushes have this new feature. Oh, it's not new. It's old by your guys' standard. But it's the feature that was designed to solve Neville's problem of not having this staccato. Right? That staccato, if you're sculpting and you want that brush stroke to be perfect, that staccato is the worst thing on the planet. So what was developed was lazy mouse. So you've got a historical trend. You've got dots to freehand to lazy mouse. And now most brushes will have lazy mouse on. Okay, but why is this still so scattered and stepped if it's supposed to be an advancement over, everything before it? I'm going to leave that up for a sec. Anybody know? Why is this still so stepped? There's one feature that's just not set up. Roll distance is possible, but not in this case. But Israel's got it. It's the lazy steps, right? It's this guy right here. So this is set too high. If I want it to be really smooth, like that, then I need to increase or decrease the lazy step. So if you're wondering what is lazy step, how that functions, thankfully the screen in front of us can actually describe it all. All brush systems, basically, at least all the ones I'm familiar with, follow a very simple coding system. So basically they're all dots. And you can see this inside of Photoshop, for example. When you go and you adjust brush spacing, then you'll see, either the dots get further apart or they get closer together. And that's what you're seeing. You see, that's one dot, 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 dot. That's just an animation. It's just like, hey, every second, put a new dot down. or every quarter of a second or every tenth of a second put a dot down, and then as the computer gets overwhelmed or underwhelmed, you're either putting fewer dots in or more dots in. So it dynamically adapts to the computer's resources. Because in this case, the role of these brushes is to make them as freehand as possible. So there's this trade-off, If I want the brush to respond naturally, then, well, in the beginning, I might be able to catch some of those dots, but as it moves too fast, the computer just can't capture it because I'm moving too fast. That's the dilemma that we're solving here with strokes. If I move slow, then the computer's got time to figure it all out and make sure that everything's evenly spaced. But who wants to draw slow like that? It's very inartistic. It's annoying. We want to be able to go, sha, whooshba, put something in. What is it? I do not know. And then what? And we have something, and then let's put some spiky hair. And you're done. That's more artistic, if undecipherable. So what lazy step does is it just says, hey, cool, I know this is what you really want to do. I know that you want to make this really nice line stroke. I tell you what, cool, you make that nice line stroke. I'm going to chill out back here, and I'm just going to make sure everything happens correctly. Like I'm going to go back in space and make sure that all these things are neatly arranged. So lazy brushes, which I told him at the time, it's really not. It's not named in the best way possible, because it's really not lazy mouse. It's like lazy artist is their implication there. I don't want to be precise, So lazy step is going to be your friend. It just goes back in space. How far back it hangs out is lazy radius. So for example, you barely even notice my stroke here. But as I increase lazy radius, you see how far back it hangs out? So that can do some cool things in terms of when you're making fluid strokes. You set your lazy radius really far back, and then you get this kind of nice little trail. But that's not usually used. Lazy smooth is just like all the other smooth. In essence, you're seeing a smoothing between these strokes. So lazy mouse is not only making these more consistent, it's also smoothing between them. In general, it's unnecessary to add that. So it usually stays pretty low. Now, on top of lazy mouse, there was other things added like backtrack. Very few brushes use this. This was like one of those features where when you saw it demoed, you're like, hey, that's awesome. How did you do that? And then when you did it, you're like, man, this is what? What do you want me to do? I'm not feeling very good here. This was a little bit of a harder brush to manage, or a harder stroke feature, so it doesn't get a lot of traction. Okay, and remember, as I'm explaining these things, I'm kind of explaining the history, and that's not because we want to know the history of ZBrush. It's so that you can kind of know how the features all fit together. Dots to freehand to lazy mouse. That's a crystal clear trajectory for you. There was then backtrack, but that just was kind of hard because you had to draw a line and then you had to track back over that line. And so backtrack was really an effort to make lazy mouse more controllable. Like for example, I want to do something in a straight line right here. Well, now we go and we say backtrack. Let's go here. Let's go and do line, not plane. Here's my backtrack, and voila, right? And if I snap it to track, boom, no matter where I go, left, right, or whatnot, I got a nice little line. So this was this feature that was developed. Say, hey, let's say you want to add like some kind of mechanical groove in there, and you want a straight line. This is pretty neat. We could do something like that. But like I said, this act of going back, shoot, over it was confusing. Not to mention if you didn't have snap to track, then it would kind of go all over the place, which was kind of like lazy. And then there was a plane and a line, and so plane was polish, and people were going, oh, what? And then there's spline and path, and let's skip that. Instead, curve mode comes in. And curve mode becomes this thing where it's like, hey, you draw a curve, and then you kind of click on that curve. That's kind of neat. So it's much more functional than backtrack for that primary impulse, which was, how do I get more control over my form? So we go from dots to freehand to give us a little bit more, control over the look of the brush. Then we go to lazy mouse for what ultimately was the full solution. It was lazy mouse is a very, very solid feature, and will no doubt at some point just be completely integrated. You won't even know you're using it. It's now the default. But some brushes don't use it. They don't need it, so it doesn't matter. And then now curve mode gives you that ability to be still freehand. I still get to kind of draw some shape. I don't have to like go to a box modeling program, but I have a lot more control over that shape because you can change the shape of it, adjust the dimensions, things like that. How you doing? We talked about Z-add, we talked about stroke, we talked about alpha a little bit. Let me check in with you. Noah, you can change the default of lazy step for each brush, but you have to save that brush. Okay, Frank's doing good. Any questions? Now's a great time. Simon, I really don't know what I'm doing with the curve brush yet, but they seem like they're handy. Yeah, that's fine. If you don't have a need for it, it's going to seem a little strange. And curve mode is a higher level brush. So I wouldn't sweat that brush right now. I wouldn't sweat that feature, sorry. I am going to delete that curve. So if anybody was following along and they want to get rid of this little curve here, you got to go into curve function and delete. That's important to keep in mind because it's like a two-step operation. So you got to, once it's there, it's helpful to delete it. James, easier to create an alpha outside of ZBrush, or can you do something within? You can do alphas in ZBrush. In fact, we'll probably do that today, and outside as well. And Stefan says, yeah, you can grab the dock. Okay, let's talk about type. And I wonder if I can get this guy a little higher. What was he at? 1 million. Let's see if we get into any trouble by subdividing one more time. He's going to go to about 6.5 million, 7 million now. If it causes problems with GoToWebinar, then I will I'll reduce him. So let me know, guys, if you experience a lag, because that's when there'll be some problem between the two systems. Okay, one more question, Israel. Regarding curve mode, I often have a problem when I click the curve line after changing my brush, the curve doesn't change size as it's meant to. When I click the... Israel, it can depend on a couple of things. Let's say, for example, turn curve back on. Right? Is your cursor blue or red? If your cursor is blue, you can change the size there as well. And that's going to be different than changing the size outside. So you got to make sure it's red when you're changing that size. Okay. And curve function and delete, and we are good. So I'm going to just throw that into the center to get rid of it. That is also how you get rid of features that you put on the interface. I think I forgot to cover that. So enable customize. If you want to get rid of AccuCurve, Control Alt, drag it into the center, get rid of it. Alrighty. Now brush types. We got to spend a little bit of time here because brush types is where the core of research really goes. And this is where you're going to see ZBrush really shine. Really shine. This is actually where they're leading the way. It's the reason why, well, all of this stuff we're talking about now is the reason why we're even in this class, why we're even talking about ZBrush. It's an artistic program. You get into it, you feel like it understands you. You feel like this is, you know, made for you, because it is. Once you're into the system, there's so much awesome stuff happening. And it's all so artistic in the sense of it follows your brush stroke. It doesn't have a lot of crazy interface stuff. It's just get in there and start to sculpt. And so a large part of what they do is try to figure out how to get the program out of the way. So let's talk a little bit about the evolution of brushes. It'll be in the lectures as well, but I want to make sure we talk a little bit about it. So in the beginning, there was not these thousands of brushes that you see here. There was really only a few. Let me get that out of the way. So B, there we go. So standard brush, where'd you go? Standard brush right here was a big one. Right? And what we're going to really see is brushes that are topology dependent, and then brushes that are independent. And independent topology brushes is really what's kind of helped take us to the next level inside of ZBrush. And it's really helped take all the other applications that do digital sculpting to the next level, because Pixologic was the first ones to kind of to start working on this. So the ability to not care what your topology is doing is really important, because that's one of the key features why people would use low subdivision levels. It's because on high subdivision levels, the standard brush did not work. It just didn't do things right. Bad things would start to happen. Standard brush has been optimized, so it's actually better at that stuff now, but it's still not truly independent. The independent brushes are clay. So these are the two different competing philosophies inside of ZBrush, the clay brush versus the standard brush. Those are the two cores. The other brushes that were kind of started with ZBrush were things like, with the standard brush, it's like layer, where'd inflate go? It's right in front of me. Inflate, pinch. Those are kind of the older brushes. But now clay buildup, then there's planar brushes, like let's say H polish, and then just the polish brushes alone. These can be very powerful. Trim dynamic, very, very, very powerful. And then we've got these really cool brushes like trims and the slices and the clips. Where'd the clips go? Okay, those are all added. Those are also essentially topology independent. They have different things that make that happen. And then we've got these really new things that have cropped up, like the insert brushes. So these are definitely topology independent. They bring their own topology. And they require the whole brush system to be focused on topology independence. Okay. So topology dependent, topology independent is really the kind of key deciding factor here. And at the heart of it is the behavior. So what is the brush doing? And what can we do with the brush? So let's take the very simple example of a polysphere. I'm going to, let's see, is this actual? Yeah, it converted it. Okay. Let's Dynamesh this because it's going to be a little, there we go. Okay, at the heart of this is the ability to get control over your sculpting. And so what do sculptors need to do? Help me out here. What do sculptors really work on when they're sculpting? Of course, we're dealing with anatomy, we're dealing with form, but in terms of the pure nuts and bolts, what is it that we're working on? I'll give you a hint for the discussion. So we're working on edges, right? Anybody else want to chime in? What else are we as sculptors, or yeah, what else is we as sculptors working on? So we've got edges, which is a lot like what draftsmen work on. They work on the edge control. Painters do it. They have the dry brush techniques. They've kind of run a brush over an edge to kind of blur it and make it more atmospheric. We've got volume, as Norman says. We've got shape, yeah, so there's anatomy. So volume is kind of a significant thing. I'd say volume over shape, because volume is saying, can we create a kind of smooth contour? You know, how do we build smooth planes? So planar aspects are really important. Structure, but what part of structure? So that's where planes, edges, curves, curvature become significant. These are the components of it all. If you're sculpting in clay, you need to have a way to kind of create some really smooth curves. So you might take a real simple metal shim, right? With a little bit of handle here to help your hands. You take a little metal shim and you just run it along the sides. And that alone starts to kind of help you make a real nice clean cut. Let's say you need to gouge something out. So you take a little loop tool. And then we got an even bigger gouge at the side, which is totally unmanageably large. Maybe you cut little notches in there like Richard McDonald does to kind of help create texture as well as help pull form. These are all the things that, and when we're sculpting, we have to deal with. So at the heart of ZBrush, it's trying to allow you to kind of manage this whole spectrum of sculpting. And so in the lessons, you'll see something that, this little axis that says, hey, we sculpt loosely and we sculpt defined, right? We sculpt hard and we sculpt soft surfaces. So the features need to be able to adapt to the ways in which we operate as artists and the topics and the things in which we try to create. And they're all arranged along these lines. And so I'm going to demonstrate that right now. You'll also see this demonstrated in the lecture, but I think it's a really good thing to kind of do it in front of you multiple times. So all sculpting, in my mind, can be distilled down to taking a sphere and turning it into a cube. Can you take a sphere and turn it into a cube? That's a very good test to know if your application is giving somebody the control that they need to be able to work. So in the olden days, you would use the standard brush. So I'm going to just come in here and reset all brushes, by the way. So I get rid of any alphas or strokes or anything I had set up. So we could start to press Alt, smooth out, but see, smooth's not working at this high subdivision level. Smooth out, again, not working. And we could eventually get somewhere. It'd take a lot of work, but we could kind of eventually get that into some sort of diamond or some sort of cube, I mean, and we could certainly increase our symmetry. So let's undo this. Let's fix the symmetry issue right off the bat. So let's do Y and Z. Yeah. There. So that's the first thing that we can do to start to help us get some sense out of this. And if we had the lower subdivision level, we would actually be doing pretty good right now because we would be smoothing all of this stuff out. So let's really Dynamesh that down. So I set my Dynamesh resolution to 16. I'm going to smooth this out. And then I'm going to turn Dynamesh off and divide it. Voila! You probably thought you were just going to look at another demonstration of a guy sculpting a cube. It's a great test of how you think about sculpting. And it, gets away from all the anatomy and all of that stuff. So I was able to do it using the standard brush and smooth, and also the Dynamesh feature to kind of help me deal with resolution levels. So the system as it is today is pretty solid. But let's say if I'm going to start to divide this, and now I really want to get really tight control. I want this edge to be nice. You see this chatter I'm getting on the edges? That chatter I want to control, right? So I go back into my stroke, lazy mouse. Lazy mouse was off, and then there we go. Okay, but now it's very powerful. So that's its own problem. And I have to smooth this down. And so this is that process you see guys like Zach Petrock doing in the old days. He does it differently now. But in the old days, this is the process you see where they will come in and work. They'll make a line, they'll smooth it out, and then they're careful what they smooth. They don't smooth everything. And you kind of build it up from there. But there's problems. So then you might do things like, let's turn perspective off, mask an edge, okay, and then you might smooth that out. And through masks, you might be able to start to get this hard edge. Okay, but what's the problem from, if you're designing software, what's the problem from the tool sets that I've used right now? I've used masks, I've used Dynamesh, and I've used the standard brush and smooth. Okay. Where does each one of those features fit in terms of loose, or let's say freehand, controlled? Where does Dynamesh work in this kind of freehand, this controlled kind of mechanism? Where are masks? Are masks a freehand way, or are they more of a controlled way? Is the smooth brush freehand or controlled? What do you guys think? These are the kinds of things that the dev team is thinking when they put together these systems and these features. Sure, we can help somebody create a hard surface box inside of ZBrush using more controlled features like like some of these edge loop features that were in there before. Or they can do Dynamesh, which is kind of in the middle in my opinion, right? Or masks, which is, it's kind of freehand, but we didn't use it freehand. You can draw them on there, but we used it in a different way. In fact, the way we used the mask by drawing out the shape and then just smoothing that shape was actually a very mechanical process. You could write a program to do that. There was almost no serious human activity involved in that, so I would say the way in which we had used it was a very controlled approach. A program could be written to do that. That is not the direction that Pixologic wants the majority of their features to be in, because there's already a ton of programs that do that. There's a ton of programs that do it. It has some of it in ZBrush, but ZBrush is up here in freehand land. Remember the diagram. You've got Maya, Max, you've got Lightwave. These are all back here in hard surface controlled methods. ZBrush, was pioneering freehand and organic. Doesn't mean they got everything right. But you guys are familiar with lean startups, right? Scrums, organizational techniques where the minimally viable product. With all these comedies coming out nowadays, it should be entering everybody's vocabulary. What's a minimally viable product? Minimally viable means, you just get the core features. That's what ZBrush did in ZBrush 2, and it's added from there. So anyways, this is all to tell you that the way in which I was just getting a square was a controlled method. And I know half of you guys are thinking, oh man, but I really loved that. Because that programmer in you is thinking, finally, something that makes sense. Some system I can apply that always works the same way. But we're going to now start to kind of go from controlled to freehand. So instead of doing it this way, let's just duplicate this guy. We're going to go back in time, see if there's another way for us to do that. As Noah says, use the slice tool. And Noah, I can tell the engineer is strong with you. But let's let the engineer have his day another time. We want to try to do this as a Luddite, a technophobe, somebody who lives in clay, who doesn't even know what email is. We want to do this freehand, like cavemen. Sorry, sculptors. All right, this is where we get into clay. I'm going to use clay and just clay, nothing else. Notice the difference, right? Notice how flat that is. That's what topology independence is all about. You notice back here with the standard brush when we did the same thing, it's like, whoa. It's not nearly as clean. The clay brush has advanced algorithms to help it maintain surface continuity. All kinds of crazy stuff. It's amazing. The clay brush is amazing. So we can come in here and we can say start to find these edges. You can see you can see, it's got the same dots that standard brush had, but it solves them cleaner. So without too much work, we're getting a better result, but it's still quite loose. So we need to put some time into some features here. Okay. The other one, the old school one's looking better, but we got better faster with this clay brush. Okay, now of course we can come in and go the engineering mindset and smooth this out and get ourselves a hard surface, but that's not what we want to do. We want to see if there's a way for us to use these brushes to kind of get more control to be able to sculpt this cleaner. So the Luddite approach would be to smaller brush, move your actions to become smaller in terms of how you function here. But I'm done with the Luddite. Let's see if we can still keep it freehand. It's a magic tool, and we come in and select, let's say, H polish. Where did it go? Look at that brush. What? Oh my God, it's like magic. I went a little too far on the top. Look how clean those are. Let's turn perspective back on. That is very solid edge control. What kind of brush is the H polish brush? I mean, what kind of magic is this? Well, the base type is polish, which I can tell you is a short distance from the clay brush, just because I know these things. Polish brush is using a lot of the similar algorithmic stuff as clay. So they're very, very similar. Let's see, what's polish brush called? Yeah, good. It's called that. Okay. So now we solved the edge problem, right? Not the edge problem. We've solved the plane problem because we were having the plane problem here, and in order to fix it, we had to use this mechanical controlled approach, smooth, mask, all that business. We didn't have to do any of that, and we got a better plane. That is beautiful structure. But, well, we have edge. This is a great edge. Really awesome edge. But we don't have that. The problem now is when the edges come together in 2 or more planes, then we're going to have problems there. So we can try a couple of things. We can come in with H polish and press Alt, hoping that H polish will build form up, but it's not. It's only going to cut form down. Whoop. Wait, something's wrong. Okay, never mind. It's just not going to function the way I want. All right, it's the nature of let's undo that. It's the nature of the H polish where its algorithm does not allow it to add form terribly well. Let's try the polish brush itself though, because then it doesn't have a certain algorithm intact. I'm pressing Alt. I'm going to switch over to Z sub. I'm going to switch over to Z add. And this brush just, well, I can add this way, but you see how it keeps wanting to, it finds out what the normal is, and then all it does is it just pulls geometry up into that plane. It's not moving that closer. It's just like, hey, that's the direction you want? Cool. Now let's take everything in that brush area of influence and move it up. That is algorithmic behavior. You can't really get around that. Like, you'll find problems like this with different brushes where they're just not working, and a modifier can help, but in general it means you need to switch tools. Okay, let's try trim dynamic. I'm going to press Alt. It's very similar to polish. You know, it's still doing that plane. Let's see, can we do H polish now? Since we were able to add something, can we then just H polish this as though we just added in a little piece? Well, it's a two-stepper, but it's not horrible, right? That's one way that we could kind of work, but the two-step creates its own problems with H polish that we then need to mitigate. But we're getting there in our ability to kind of quickly create this kind of form. Another approach that we could have taken would have been early on to help get that a little bit cleaner. So let's go back to clay brush, and we'll just make the cube smaller and solve that problem earlier. Before we get to the H polish stage. Adding. Okay, and maybe a little bit of smoothing. Make sure we've got the basic shape before we go into the polishing stage. Because once we're in the polishing stage, it's different. So we all know this from carpentry or different things that you do. Sometimes you add these extra steps in so that it can get removed easier. So this is one of those that really just needs this to be cleaner. I just need a little dab of clay right there. Cool. Boom, H polish. Okay, then it's a one-time polish on the sides. So it's a very clean, uniform surface. One-time polish. Did I go too far? No. And then a one-time polish. Okay, done. Super quick, super simple. And what was the single most important part of that workflow? Let me look through your questions right now, and then tell me, what was the single most important part of that workflow? Was it something ZBrush did? Was it something I did? Was it a feature? What helped me get hard edges better than than the other methods before? Let's see, I'm reading Mark right now. Yeah, Mark's got the build-up right. Carlos, in my sculpting class in university, when I sculpted a cube, I threw it against the wall to make the corners. If you're in clay, yeah, that works. If you're not in clay, that's a little hard on the computers, as David says. And Simon's right. You know, it's adding mass and then removing it. But I would say it another way. The thing that made the single biggest impact is my workflow. I didn't change the tools between this surface and this surface. I just changed the order in which I did things. And I made sure that these edges had extra geometry. And this is a common thing we as sculptors encounter. And it's why, you know, some old school sculptors that have been doing it for a while, you'll notice that they have a very specific method, and they're more cautious in some things, like building a life size. You don't just throw a bunch of clay, you know, because the whole thing is going to collapse down, and just, you know, you're going to lose half a year of work. if you don't do things properly. We have less of a problem inside of ZBrush with do things properly, but if you do things properly, these edges happen magically. And all you got to do is just be aware of the limitations of clay, polish, standard, and adjust accordingly, which is what this class is all about. Yeah, as Aaron says, anticipate the quirks of the tool is what it's all about. Okay, so that really kind of helps us understand a little bit about the clay, the standard brush, and a little bit about workflow. Let's talk about a couple of other brush types, and then we can kind of move on. Which one was I working on? Is it this one? And he's at, yeah, 7 million. Okay. So something you'll see guys do frequently to help build form. Let's see if I can build form here. I might have some problems, but okay. Another brush that can be really cool in terms, another two brushes that can be really cool in terms of their difference is inflate and magnify. So these two are kind of connected. They're meant to do the similar thing, which is to add volume in a certain way. And in doing that, you know, they behave differently. So let's talk about the way they behave. And let's do this at a lower subdivision level so I can show you the topology. So one of the things you'll see guys do, I've seen Chris Costa do it and other sculptors, they'll use inflate with a low intensity and sometimes a low focal shift, so it kind of hardens it. And they'll build form with this because it just kind of adds form in a really nice, simple way. So let's add some of that tricept. And it's coming around to the epicondyle here. Let's go up a subdivision level. Let's add, this part hasn't really been sculpted. Let's put the brachialis muscle in there. Do I have a, yeah, let's just work on that arm. And that brachialis muscle really needs to move around because that arm is twisted. But we've got the brachioradialis. Don't worry about the anatomy. I say it mostly for myself. It's just habit. When I sculpt something, you got the brachioradialis, the extensor, brevis, longus, Jingo Jangus. At the end of the day, those names get crazy. But see, this is swelling the form as well as building up the form. That's really nice. It's a great sculpting tool. Very subtle what it does. But that can make a big difference. And as sculptors, ultimately, you see how pointed that is? The difference between a properly sculpted arm right there, you know, that's just a tiny bit of clay. That's a tiny bit of clay, but it shows up. You know, it makes a difference. So there's that. Then we can try the magnify brush. Lower that Z intensity, lower that focal shift, and see if this works. This was actually the brush that the Pixelator was thinking would be great for sculpting kind of muscles. And I don't know if you can tell or not, but this has a different effect. It's real subtle. And you'll see it when we do something real extreme. Like let's just add a bump right here. I'm going to increase. And let's go to the inflate brush. Okay. So the inflate brush, really, it does move out and it does move up, but it doesn't really I don't know how to say it. It really moves vertices up and out. That's it. But I don't know if you could have noticed this or if you saw it, but when Magnify was doing its job, look at this curvature. The Magnify brush has, as part of its algorithm, it's got this kind of spherical intention. I don't know how else to say it. That sounds metaphysical. But it has this spherical intention. It is always going to try to move vertices down or up along this sphere with the hopes of it conforming to a much more spherical plan. Sometimes that's great, like in a bicep. We could want that, so boom, magnify and lower the Z intensity. Let's get, where is the insertion? There it is. So we're just going to get a little hit of it right here. Yeah, and so it's going to really work to create a nice, smooth curve, whereas the inflate brush is going to kind of be the simple version of that. Let's lower it. You see I'm tweaking this a lot more to get it, but it didn't blend the surface in very much. It was just like boom, go up, boom, go up. That's why a lot of people, when they use inflate, they use it at a very low intensity, because then you can kind of get the subtlety that you just weren't getting before. But now with the magnify brush, you know, you can get that same, like my Z intensity is at 19, I'm getting that same level of subtlety. Careful. This is not really a major sculpting brush, you know, because you before you know it, the other side, the stuff around the corner of that bicep, that's getting magnified as well. So that's being pushed out, and next thing you know, you've got a lot of form built up and you just didn't know about it. So those are things you got to be mindful of. See how much got added from here to there using magnify? That you got to be very, very, very mindful of. I'm pulling it over here. Oops, let's undo. See that? Whereas inflate, inflate only focused on the brush path. It didn't adjust anything else. Okay. And let me stop there for a second, because that difference between magnify and inflate I was going over, mostly because I wasn't sure I was explaining it correctly. So let me ask you if I explained it and if it makes sense. That magnify has sort of like an AI that gets added. Any questions? Is it working for you guys? I'm reading your thoughts right, or your comments right now. Okay, let me just move on. So inflate and magnify. Magnify is new, inflate is old. New adds these AI elements. It's, you know, quote unquote AI. Basically adds these kind of elements where it's trying to define what your overall intent is and then make it take advantage of more things, like a brush that could add gravity when you sculpt it to create a cloth fold instead of sculpting the cloth fold manually. That's the kind of stuff that I know Pixologic would be really intrigued in. Ashok's got a great explanation. He says inflate means expand, magnify means scale. I think that's a cool way to look at it. I'm not opposed to that. Okay, so we've gone through types, Z-add, strokes. Oh, you know what? There's one more type because it's a crazy type. Pump. got to show you guys this. I just love this. And this is much better at a higher resolution. And let's focus on the body. So blob brush. This kind of fits in line with that inflate magnify option. You could say here's inflate. Here is magnify. And then here's blob. They all kind of fit within that same spectrum of behavior. Which one you choose, you know, kind of is kind of up to you. Blob will do a lot to modify topology. You can see that modified topology. It's really spreading things out. So it's designed to minimize upward movement, maximize lateral movement. That's what this brush's algorithm does. It decides to displace things left and right as opposed to vertically or along the normal, whatever the case may be. A couple of cool uses. Take it over into spray stroke. Come in with some crazy alpha like 23. What subdiv are we at? That's the question. Okay. You can get some crazy forms this way. Not so intense. Let's go that way. You know, some kind of virus, super easy. The more you do it, the more modeled that gets. Wounds, concrete, damaged, cement, if not just the cement surface's natural form. Very easy, very simple to make that kind of happen. Now, there is another feature we kind of need to talk about. So we talked about AccuCurve.